There are probably 2 million asteroids in our solar system.
The reason that Psyche is unique is that it is metal-rich.
It's believed that it may be a remnant core of an early planetesimal.
One of the ingredients that went into making our Earth, and one that we cannot see any other way. And it would be the first metal object that humankind has ever visited.
Studying the evolution of a planetary body is a detective story.
I think the only thing we know is that it's not going to look like what we think it's going to look like, and it's going to be really interesting, whatever we find.
Space is always more amazing than we can imagine with our minds.
Good afternoon and welcome to NASA's Kennedy Space Center. I'm Jasmine Hopkins and you are watching the pre-launch news conference for NASA's mission to Psyche. This mission will take us to a metal world for the first time and allow us to test deep space laser communications along the way. The Psyche mission is set to lift off aboard a SpaceX Falcon Heavy tomorrow, that's October 12th at 10:16 a.m. Eastern. And this is a coast-to-coast NASA mission managed by NASA's Jet Propulsion Laboratory in California and launching from Florida's Space Coast. We have joining us today a distinguished panel of guests ready to talk to you about this mission. Starting from my left, we have NASA's Associate Administrator, Bob Cabana, followed by Dr. Nikki Fox, Associate Administrator for NASA Science. Henry Stone, Psyche Project Manager from NASA's Jet Propulsion Laboratory, followed by Tim Dunn, Senior Launch Director from NASA's Launch Services Program. Juliana Scheiman, Director of NASA Satellite Missions from SpaceX, and finally, Arlena Moses, the Launch Weather Officer from the U.S. Space Force. Our panel will be taking questions from the media here in the room, over the phone, and for those of you online using hashtag AskNASA. But before we get to those questions, they'll each take a moment for opening remarks. So, Bob Cabana, we'll start with you.
Thank you, Jasmine. Well, it's always great to come back to KSC, especially for this amazing science mission we're going to launch. You know, this is an incredible time for space exploration. We are on a trajectory to go supersonic, to go to the moon, to go to asteroids and to the furthest reaches of our universe. We're getting ready to launch this really amazing mission to Psyche, and it really leans into NASA's mission statement, the explore the unknown part. We're going to explore to increase our knowledge and to discover things we don't know, and in order to do that, we need to innovate. We create new technologies that benefit humanity. And then we make discoveries that not only expand our knowledge and understanding of the universe, but they inspire all of us. They inspire new generations to explore. You know, I get the opportunity to see all of NASA's portfolio as I travel across NASA and go to the different centers. And I got to tell you, it is just absolutely amazing all the cool things that we're doing. As a pilot, I'm always interested in what we're doing in aeronautics. And when I look at the Sustainable Flight Demonstrator, the X-59 Quest, the low-boom supersonic aircraft, this is going to change the way we fly in the future. Then, you know, we got another outstanding crew on the International Space Station. It's really hard to believe, but this December, it will have been 25 years since I had the privilege of laying the cornerstone of that amazing vehicle that's up there right now. And right now, this truly is the decade of science on the International Space Station. All the things that we're learning, it's just a phenomenal lab that's up there. I'd also like to point out that the space station is just one of 20 missions that we have studying our own planet Earth. And a lot of people don't realize that the planet that NASA studies the most is planet Earth. Every time I come to KSC, I just love to see the progress that is being made on Artemis in going back to the moon and beyond and eventually on to Mars. And it's really important work. This is work that is important to our nation. It's important to advancing U.S. competitiveness. It's keeping us a global leader. And other nations look to us to continue to lead. And we're not just doing this alone. NASA brings the teams together, our industry and our commercial partners, our international partners, to explore beyond our home planet. We're making that happen. I am so proud of the science team and the Space Technology Mission Directorate for the Psyche mission and for the deep space optical comm that's going to go along on this flight. Absolutely amazing. Psyche, of course, as you heard, is the first time we're going to a metal world. All the times before, we've gone to planets and objects that are rock and ice, but tomorrow we're going to go to a metal-rich asteroid, also named Psyche, 2.2 billion miles away from Earth. And I didn't say it, but you know, this truly is a heavy metal rock that we're going to, and you guys can figure out whatever that means, all right? But I'm going to turn it over to Nikki in science to tell us more about the mission. Nikki?
Thank you so much. It is so great to be here. As Bob says, it's amazing to come back to Kennedy, and I love coming here anyway, but when we come here for a launch, it's just so special seeing the team in their final throes ready to go. And of course, we hope that when we get to this metal world, it will just kind of reveal a treasure trove of scientific discovery and potential answers to our deepest questions about the solar system's history and our place in it. And of course, not just answers to the questions we have today, but we're scientists, more questions. We always get more questions when we get there. And we hope that by studying the asteroid, we'll learn more about the iron core of other planets in our solar system, including, as Bob said, the most important planet to us, the one we live in, the one we live on. And so we want to, we want to learn more about that core. It's impossible for us to actually go and study the core, but man, we can study that asteroid, and that will tell us all about our core. The origin of the asteroid itself is a mystery, and we hope to uncover that when we get there in 2029, because finding out where it came from will teach us about the formation of our solar system. Right now, scientists believe that the asteroid Psyche could be part of a metal-rich interior from the remnants of a small planet known as a planetesimal. But there's also a belief that it could be a totally new type of primordial solar system object that's never been seen before. We have 4 science instruments on board the Psyche spacecraft, and of course that will help us study the asteroid, and I'm hoping that many of you were able to attend the science briefing yesterday where you heard all about the incredible science that we're going to be doing. And we've also got a really innovative mission design where Psyche, once it goes into orbit around the asteroid, will go at 4 different altitude profiles, starting at about 440 miles above the asteroid, going all the way into just 47 miles above the asteroid, which is freaking cool. And then back up to the final altitude of 188 miles above the surface. And we'll just keep going, collecting all the information about the asteroid's mineral composition, the topography, all the element composition, the magnetic field, and of course the gravity. Psyche is our 14th mission as part of NASA's Discovery program. It's managed by the Marshall Space Flight Center. Our Discovery program really comprises low-cost, really high-quality, high-value planetary science missions led by a principal investigator. Of course, shout out to our current favorite PI, Lindy Elkins-Tanton, who will be watching her baby fly very soon. Obviously it enables NASA science to provide science missions that explore for the benefit of all and discover science that will last through generations. I do want to quickly acknowledge our contributing partners, the University of Arizona for leading the Psyche mission, and that's our home institution of our amazing PI. NASA's JPL, Jet Propulsion Lab, are responsible for the mission's overall management, the system engineering, the integration and testing, the operations, just doing a phenomenal job as always at JPL. Maxar Technologies, who delivered the solar electric propulsion chassis, the main body of the spacecraft, and most of the engineering hardware. NASA's Kennedy Space Center's Launch Services Program, who manage the operations, and they're kind of important, SpaceX. They're going to launch us on a Falcon Heavy rocket. Obviously, you know that Psyche was delayed from launching last year due to critical testing not being completed in time for the launch window. Man, is this year a totally different story. I am so proud of this team, the whole team, and I'm so happy to say that after a year of just nonstop work, we are absolutely ready to go. So I look forward to having Psyche. I have to mention OSIRIS-REx because you've all just seen those samples. So I'm really looking forward to having Psyche join OSIRIS-REx and Lucy that are exploring our solar system during Welcome to Asteroid Autumn. And it's one of our sort of engagement opportunities that we have in the Science Mission Directorate, with our goal to make science more accessible for all. We really want to lower the boundaries. We want to have everybody knowing that they're a scientist. You do not have to have a PhD to be a scientist. You just have to love asking questions. You're a scientist. So join us. We also will kick off on Saturday. The Heliophysics Big Year kicks off with the annular solar eclipse. That's another great way to information center that recently opened at NASA headquarters. You can also see that virtually. Again, please join us. Join us and do science. But for today, we are ready. We have a heavy metal mission. We're going to rock and roll it. Go Psyche.
Awesome. Thank you so much, Dr. Fox. Posing for the photo. Wonderful, Dr. Fox. All right, now let's hear from Henry Stone.
All right. Good afternoon, everybody. And it's just a real pleasure to be up here and for all of you to be joining. A couple of comments I'll make in my open here. First of all, beginning, I want to start off by letting you know that the spacecraft is completely ready to go, right? It's been fueled. It's fully integrated onto the rocket, obviously. The rocket's now upright and vertical, as I'm sure you all know. The final version of the flight software has already been loaded on the vehicle. The final set of flight parameters that are necessary for launch have been loaded, so it's ready to go. Only thing that stands in our way, sorry, Arlene, is the weather. She'll brief us a little bit on that appropriate weather to go, and hopefully that will be tomorrow, but we'll see. I would like to show a couple of pictures here, just kind of evidence of some of this. Where are my pictures? Okay, so starting on the left there, you can see the spacecraft mounted up on top of the IMA, which is a shock isolation device, the PEF below that, and then the PA, the PAF at the bottom, which is our payload adapter fitting, and that's where we then attach on to that beautiful rocket that we're going to be taking off on. I love the next picture after that. You can see the fairing during the integration activity there. And if you look right down the center of the opening, you'll see the spacecraft poked in, and then we closed and sealed her up. So it's in the fairing, on the rocket, and ready to go. So you're all probably sitting there asking, okay, well, so what happened? We were going to go off last week. We moved it to today. A number of weeks ago, we were doing some additional testing at JPL on the cold gas thrusters. We're to further do some characterization to provide additional data out of abundance of caution and everything else for our operations team, to have more data so that when we're in flight they could understand exactly what was going on. During those tests, we discovered a discrepancy with some earlier tests that we had run way back that we were using in the thermal control of those devices. Needless to say, we were concerned about that, so we embarked upon a program over the last several weeks to do further testing on the actual flight spares that we have, make some adjustment to our flight parameters. And that's something you don't do willy-nilly and just wing them out there, right? So we wanted to make sure we took the time and needed a week to make sure that we ran all of our testing and our verification again, that the adjustments to those parameters would be appropriate. This is a huge investment, a mission like this, and we wanted to be absolutely sure that we are ready to go. And we completed that activity in the scheduled week that we took. We reviewed those results with the headquarters and and all of the various stakeholders, and as I say, we're ready to go. I think the other thing I'd just like to spend a few moments on is give you, and you'll probably have some further questions, but a preview on kind of what to expect, right? What's the initial timeline here? When are we going to hear from the spacecraft and that we're off and running? So the spacecraft will be powered up about 5 or so hours before the actual launch, and that will be handled by a crew of our ATLO, our Assembly Test and Launch Operation team that's been located down here at the Cape. They will handle that in conjunction and parallel with the operations that are taking place on the launch vehicle in preparation for the countdown. We will go through the countdown with the launch vehicle. The spacecraft itself will be transitioned through an initial test mode when it's initially powered up into a pre-launch mode and the launch state, all configured finally at the end. Then that great rocket's going to blast us off and mark the actual start of the mission. Separation of the vehicle, of the spacecraft from the launch vehicle occurs approximately 1 hour after launch. And the vehicle autonomously, the first thing that it's going to do is to stretch out those big, beautiful solar arrays that you see there. This is a solar electric powered mission. Those will be deployed autonomously, one at a time, all of the 2 wings going out and spreading out. The spacecraft will autonomously be using sun sensors to search for the direction of the sun so that we can orient the vehicle, get those sun panels directly on sun and go power positive so we are no longer using the batteries to power the vehicle. Shortly after launch, when we do that and when we're looking at the sun, we're going to be generating 20 kilowatts of power on board. At that point, we will start to rotate the vehicle very slowly. Because we may or may not have our low-gain antenna for communicating to Earth pointed in the view towards Earth. So we will rotate and spin because Earth will kind of be off to our side, right? And once we detect where it is, start picking up carrier and potentially telemetry, we will send a command to the spacecraft to continue one more rotation until it gets right to that point to get us lined up. To have the low-gain antenna pointing to Earth so we can actually start on our continuous communications. So it's really going to be those set of operations are going to take, roughly about 2 hours or so after separation before we are assured or have high confidence that we will have locked in, be in position to start to get actual telemetry. However, it is possible, depending on the orientation we get dropped off from the launch vehicle, that we may have carrier and or telemetry much earlier and or intermittently. So I just want to set everybody's expectations about, because I know the control team at JPL, which we'll be handing this off to, is going to be very eager to see those signals. So we'll be getting information as to whether and when we start detecting carrier, when we go into a full lockup so that we can get the telemetry. We'll get an initial dump of that telemetry, and then we'll do an assessment of the overall health of the vehicle within several hours after the separation event. So that's kind of the general high-level timeline. Let me see if I could I had a photo here. Like I said, we have 2 teams. The vast majority of the project is actually located at our mission support area back in California at the Jet Propulsion Laboratory. Here is kind of a picture of one of the rooms. You've probably seen this control room for other missions. But that's the team that we'll be handing off. So as soon as we separate, that's where all the action will take place, and our team here at KSC will be prepared to stand down and move back to California. So just endeavors of this size take an extraordinary number of people with extraordinary talents. And we've had that on this project. And it's not only within the project, but all the supporting organizations here and LSP and SpaceX to make a mission like this possible. And I just want to extend my thanks to them and just express that it's just been an honor to have the opportunity to sit in this seat as the project manager and lead this activity. So again, thrilled to be here. I'm thrilled that you are all here and the public watching to join us in the start of a remarkable mission to an extraordinary place, a metal-rich world. Thank you.
Thank you so much, Henry Stone. Next, we'll hear from Tim Dunn from the Launch Services Program.
Thank you, Jasmine. So I'm proud to be here today representing the women and men of NASA's Launch Services Program. I'm the launch director for the Psyche mission, and I'm thrilled to be a small part of the amazing team that's launching this spacecraft. Psyche is the 7th NASA LSP mission to launch on a SpaceX rocket and NASA's first mission to fly on the massive Falcon Heavy. Psyche will depart from Earth from historic Launch Complex 39A right here at Kennedy Space Center. It's the second time we in LSP have gotten to launch from this pad that has previously hosted such venerable vehicles as the Saturn V and Space Shuttle. I'm glad you mentioned it, Henry, but I would like to recognize the Falcon Heavy Psyche launch team, SpaceX, NASA headquarters, NASA Kennedy Space Center, the Jet Propulsion Laboratory, and of course, the United States Space Force's Space Launch Delta 45. This assembled group of professionals is truly world-class as it's executing the Psyche launch campaign with surgical precision. While we represent our agencies and our organizations, it's amazing the incredible people that are putting their hands on the hardware and making this Psyche mission happen. Henry alluded to it, and I just wish for a moment that you guys could see some of the behind-the-scenes integrated activities across agencies, across organizations to get the job done. It's really fascinating, and absolutely this part of a launch campaign is so pleasurable for me personally to see how the team comes together to execute this amazing mission. But that entire Falcon Heavy team has been busy with final launch preparations. Just 2 weeks ago, we performed a successful mission dress rehearsal where we exercised the launch team in performing a simulated countdown. Then, a few days later, the combined launch team held our flight readiness review where we assessed readiness to go conduct a static fire of the vehicle. We came out of that review successfully, and then 2 days later, on the 30th of September, we ignited all 27 of those incredible first stage Falcon Heavy engines for 7 seconds on the pad. And that was a hugely successful test. Subsequently, we returned the Falcon Heavy into the LC-39 hangar, and then its precious cargo, the Psyche spacecraft, was mated to the rocket just this past Friday. I'd now like to show a video of the launch team's efforts to date in preparing for launch of this mission. Please roll the tape. There's the LSP patch. I love that one. So there we are in April of last year of 2022, where Psyche arrived here at the launch site. We got it into its first payload processing facility here at KSC, and we later transitioned it over to Titusville to Astrotech. Here you see the solar arrays arriving at Astrotech and being mated to the Psyche spacecraft. You're going to get a beautiful view there of the extended solar arrays there. About 25 meters across, that's about 81 feet. There is the stowed configuration of Psyche and being encapsulated with the Falcon Heavy payload fairing. There's rollout. That occurred just almost a week ago, last Thursday evening, where we rolled out, headed out to Complex 39, and that is a glamour shot of Falcon Heavy right there in the hangar out at 39A. This was at noon yesterday as we were rolling out of the hangar on our way up the ramp to the pad deck at 39A. Great shots there. And we're going to get a shot from last night. That's about 11 p.m. last night where we went vertical on the launch pad. And as you guys walk out of this building, you can look across the way and see that beautiful rocket in its gently used configuration for those side cores. But we're looking forward to seeing some of that type of video here in a few days, successful liftoff, and then obviously returning those side cores back here to the Cape for reuse on a DoD mission later this fall. And then we want to set those boosters aside and use those again for Europa Clipper next year. So they'll get some great NASA LSP use out of them. So yesterday we held the NASA SpaceX Launch Readiness Review, our LRR, and just this morning we did an LRR with Space Launch Delta 45. In both reviews, we received approval from senior NASA, JPL, SpaceX, and U.S. Space Force leadership to enter into launch countdown. As you saw yesterday at the launch pad, we did begin those final launch preparations by rolling Falcon Heavy with its mated Psyche spacecraft out to the pad deck and erecting it into the vertical launch configuration. We do have some weather challenges ahead of us that we'll deal with over the next few days, and Arlena, our launch weather officer, she's going to expertly cover that for you soon. But weather permitting, And once we come out of another weather call later this afternoon, early tomorrow morning, we're going to man consoles and perform final pressurization, vehicle checkouts, and then spacecraft transition to internal power. If all's gone well to that point, about an hour before launch, so somewhere around 9:20 a.m., we're going to begin, we'll do a poll and begin loading the cryogenic LOX and the super chilled RP-1 onto Falcon Heavy's 3 cores and its second stage. After completion of that propellant loading, along with a series of final launch vehicle checks, we are going to be ready for our targeted instantaneous T0 of launch at 10:16 and 49 seconds Eastern Daylight Time tomorrow morning. So to summarize, the Falcon Heavy rocket and the Psyche spacecraft are ready, and the launch team is prepared and excited to launch this amazing metal asteroid mission. Back to you, Jasmine.
Thank you, Tim. Now here to tell us more about Falcon Heavy, Juliana Scheiman from SpaceX.
Thank you. I'd like to start by thanking NASA and its partners, the Jet Propulsion Laboratory and Arizona State University, in support of the mission. It has been a long road to get here, but we are so excited to be at this phase of the mission, so close to liftoff, and finding out what that Psyche asteroid is made out of. Psyche is an incredibly important mission for SpaceX. As you heard Tim mention, it is the first Falcon Heavy launch we're having for NASA, and it is also the first launch for SpaceX that has required what's called Category 3 certification. This is the highest tier of certification one can get on a launch vehicle. It demonstrates that the launch vehicle is ready for NASA's most important science missions. That means Falcon Heavy has been through the ringer, whether that's design reviews, qualification testing, acceptance testing, post-flight data reviews, independent verification and validation work. Falcon Heavy is ready, and we are so excited to have Falcon Heavy be supporting the Psyche mission. The last of those reviews, you heard Tim mention, we successfully completed yesterday the launch readiness review, and we're tracking no issues on the rocket, and the rocket is looking great ahead of tomorrow. And poor Arlena has some work to do, but in Arlena we trust. After liftoff, you heard Tim mention, we'll go through a series of events, and those side boosters will separate and come back and return to land here at Cape Canaveral at landing zone 1 and 2. So for those in the area who have come to visit and watch the launch or who are living here, don't be surprised if you hear a couple of sonic booms. And really, you know, reusability is so key to SpaceX's mission, and we're so proud to have a partner like NASA who has embraced reusability. You know, you heard Tim mention the Europa Clipper mission flying on Psyche's boosters. You know, reusability is so key. It's amazing to have a partner, you know, embrace that with us. And you know, we believe it furthers both of our missions, and so we're really excited about that. We have a lot to be excited about because Falcon Heavy, this is the beginning of a suite of amazing science missions we have coming up on Falcon Heavy. So we have Psyche, we have GOES and Europa Clipper planned for next year, followed by HALO PPE, which is NASA's Lunar Gateway, and the Roman Space Telescope mission. So that is a suite of amazing science missions partnered with Falcon Heavy, and we cannot be more proud to be trusted with NASA's science missions. And that all kicks off with Psyche, hopefully tomorrow. So on behalf of everybody at SpaceX, I just want to thank NASA again for their continued confidence. Thank you.
Thank you, Juliana. And as we've heard, the weather has been mentioned several times already during today's briefing. So Arlena Moses, take it away.
Thank you. Yes, I guess last but not least, of course, is one of the things that a lot of people have touched on today. Weather is one of the big watch items for at least our primary window going into tomorrow. We're kind of all watching an area of low pressure that's developed in the Gulf of Mexico, a non-tropical area of low pressure. I know sometimes this time of year we can get tropical systems, but this one is a non-tropical one. And as it kind of approaches us here over the next 24 hours, we're going to start to see steadily decreasing, deteriorating weather here across Central Florida and the spaceport as well. So we'll start off with taking a look at our satellite imagery giving us a broader view across the southeastern U.S., Gulf of Mexico, what's going on. And the area of interest that we'll be watching here is you see the brighter colors, the whites and the oranges and the yellows. That's the kind of colder thunderstorms and cloud tops associated with that area of low pressure. And a little closer to home, there is a frontal boundary. If you guys were here earlier this week, into this past weekend, we got that nice first taste of fall that came in. That same cold front that went through us a couple days ago is now lifting back north across the Florida Peninsula, expected to arrive here late this evening into the overnight hours with the mention that steadily deteriorating weather, going to be a concern for strong winds, going to be a concern for heavy rainfall, and of course lightning, another concern here going forth kind of overnight. Now, one of the good things, I guess, with some of the latest model ones that we've been looking at is that it looks right now that that warm front is going to be a little north of us as we go into the first part of tomorrow morning. And what that's going to kind of help us out with is that should take a lot of the heaviest rainfall and best chances of storm north of us. However, we still will have a very unstable atmosphere, so there still may be some storms and rainfall around, probably lots of cloud cover, all of these things that we have concern for with our rocket launches and our Lightning launch commit criteria, which are those safety criteria that we monitor to make sure that our rocket launches stay safe. And if we want to take a look at the forecast here, we can put some numbers to kind of the general thing we've been talking about. One of the main watch items now has kind of shifted from just the storms in the area to our liftoff winds. Behind this warm front, and especially with that area of low pressure coming towards us, we expect winds to pick up very quickly out of the south and southwest. Could see 20 to 25 miles an hour, likely some stronger gusts with that as well. That's once again starting this evening and going through our launch window tomorrow morning. So right now we have 20% go conditions for our window Thursday morning, with also some concerns for anvils, which are the tops of thunderstorms. Those can produce lightning as well, and surface electric field rules, which is monitoring the electric fields here on the ground with some of our equipment. However, if we go to the next day, our first backup window Friday morning, conditions improve kind of dramatically. There's been a little back and forth with some of our models as to exactly what happens, but the general trend we expect is that low pressure is going to move into the Atlantic Ocean off to our east and bring the front back. We can't get rid of it. Bring kind of the boundary back into us, maybe just a little bit of drier air to help us out. Definitely lower winds as that approaches. You see, we're only looking about probably 7 to 12 miles an hour in that time frame. So for our first backup window Friday morning, 50% chance for go conditions, with our concerns still being associated with storms in the area where we have anvil clouds, some thick clouds, which is layered clouds, as well as cumulus clouds, which get associated with storms. Now, looking at Saturday morning on our third backup window, here is still about the same probability there, our 50% chance of go, and fairly similar conditions here where there may be some storms around, but we expect most of any storms to be after our morning launch window. So if you're here in the kind of the afternoons, it may be a little more stormier in the afternoons at that point, and winds picking back up from the west-southwest, though not as strong enough, we think right now, to be a launch weather concern going into that. So as we kind of already talked about, right now, forecast not looking the best, but a little bit of hope there with improvement, and something definitely our launch weather team, while we'll be monitoring and working with our partners at SpaceX and NASA to keep them up to date with the latest changes in our weather tomorrow. So we'll do our part to help get the rocket off safely tomorrow morning, and if not, we'll look at our backup days there. But overall, I think have a little more hope now today. I know a lot of people don't, but have a little more hope today than we've been looking at, despite that 20% go conditions for tomorrow.
Thank you. Good to see that little bit of hope for this weekend, Arlena. We appreciate that. And thank you to our entire panel for those opening remarks. So now the floor is open for questions. For media here in the room, please raise your hand and give us a moment to get a microphone to you. For those of you on the phone, please press *1 to enter the question queue. And for those of you joining the conversation online, don't forget to use #AskNASA. So we'll start here in the room. We're going to start on this corner right here.
Yeah, hi, Bill Harwood, CBS News. Two quick questions. One question, this is probably for Lindy, but At most of these news conferences, I've heard anything from 5 metal-rich asteroids are known to 9 metal-rich asteroids are known. What's the best number to put after the word about in our stories? And a launch question for you guys. What are the scrub recycle options with the Falcon Heavy? I was under the impression if you fuel it twice and don't go, you have to stand down 5 days to replenish commodities. But could you walk through that for us, just in case it comes to that? Thanks.
Yeah, I think I should start there. I'm not sure. Oh, I'm getting the finger count. 9.
Yeah, it's
The answer's 9.
It's 9, but but Psyche is by far the largest, and that's why we want to go to it, because the smaller ones are more likely to have been changed by things impacting them, whereas the big one we think is going to be completely unchanged. And I also want to apologize to Lindy. I was talking about OSIRIS-REx earlier. I said she was from the University of Arizona. She is from Arizona State. Arizona State, Devil Horns, Arizona State. I'm so sorry, Lindy.
I'll take that second part of the question, Bill. So what you're hearing on the limitations for recycle attempts is due to the vast quantity of densified locks that we use for each attempt with a Falcon Heavy configuration. That's a lot of locks we're putting on the rocket. So we have the capability to do 2 consecutive attempts by loading and counting all the way down to near T0, and then if we scrubbed out, we could do that again a second day. And then after that second attempt, have we done that, then we would be down about 5 days to replenish the locks in the ground sphere and get it into a densified state. So that's where you're hearing 2 consecutive attempts, and then there's a period of time. So obviously, knowing that that constraint on the launch operations, we handle that very carefully when we make the decision about an hour before launch on whether to load that day. So we're looking at weather, we're looking at are we working a launch vehicle issue, a spacecraft issue, so a lot goes into that. So just glancing back over the last 11 months, SpaceX has launched 4 Falcon Heavies. Of those 4, 2 of them went on the first attempt, and the other 2 went on their second attempt. So the 2 of those were DoD missions, and the other 2 were commercial missions. So SpaceX has a lot of experience in handling that, especially in the last year. So it's obviously it's a critical launch decision. We treat it with a lot of reverence because of the limited planetary window that we're dealing with in the big scheme.
All right, thank you, Nikki and Tim. All right, we're going to start here in the middle of the room again, if we can. Might give us a second to get you a mic.
Hi, Josh Jenner with Space.com. My question is for Henry. You mentioned adjustments made to the flight parameters for the spacecraft. Are these trajectory adjustments? Are these mechanical adjustments to the spacecraft? Can you go into a little more detail?
No, the parameters were associated with some of the guidance, navigation, control, and fault protection parameters to make sure that we didn't overdrive these thrusters and overheat them. So it has nothing to do with the trajectory. In fact, those changes will have nothing to do with when we arrive or anything like that to the mission at all.
Thank you, Henry. Over here in this center of the side of the room, thank you.
Stephen Young with Spaceflight Now. For Bob, it's been 33 years since your first mission, and back then NASA had a reputation for openness and transparency. I've been covering the space program for 35 years, and I have to say it has never been as difficult as it is today to get timely and accurate information from NASA. In the case of Psyche, I believe NASA knew for at least a week, perhaps longer, there was a problem with the thruster that was not divulged. And then when the launch was delayed, I think that decision was taken 2 days before we heard anything. And when we ask questions of NASA spokespeople, it seems like they're not able to speak without their words being approved by committee. And it takes an incredible amount of time to get any responses. We're told to look for the blog post. The blog post often arrives in the evening, as it did with Psyche. It often reads like gobbledygook, to be frank, and often results in more questions than we have answers for. And this is not a problem with any particular directorate. It's an agency-wide issue. And in many ways, this is a follow-up to a question that Bill had to ask after the Crew 7 launch back in August, when we also did not hear that that mission had been delayed. And NASA would not confirm it on that occasion either. So I am asking, my question is there anything that can be done with that you and your colleagues in NASA leadership to empower your spokespeople, your great team, to answer our questions and to restore NASA's reputation for openness?
Well, thanks for the question, Steve. First off, when you started out there, I thought you were going down the road that I'm really old. But now, thanks, Bill. Let me just say I appreciate the question, and I understand what you're saying, and let me look into it and see what I can do, okay?
Thank you so much, Bob. Right, back here on this side of the room with the lantern. Thank you.
Stephen Clark from Ars Technica. I think mine's pretty simple, but hopefully I can get an answer. What's the wind limit for Falcon Heavy? What's the speed we should be watching out for in the weather charts tomorrow?
So yeah, we're looking at right around 31 miles per hour is the liftoff constraint. When we're in the strong back with the clamps around the rocket, we can tolerate higher winds than that. But to commit to liftoff, that'd be the limit we're looking at, Stephen.
Thank you, Tim. Back to the room. Let's go on this side here, right here in the center.
Scott Bordeaux, Arizona State University. Arlena, you said there's a weather call, your weather meeting this afternoon. When's the latest you can make a call on whether tomorrow is a go or not, or the soonest you have to make it?
Well, that question and that decision is made in conjunction with not just us. It's a group decision that we make with all our leaders across SpaceX and NASA as well. We provide the information to help with the decision, think what's best, taking all the different factors into account for the mission.
Yeah, and I can add on to that. Yeah, we ask a lot from Arlena on continually providing the senior management team with weather data, and so we've asked for a 5 p.m. Gathering this evening. We're going to take her forecast, and then we're going to make a call as to whether it's prudent to bring the team in for a launch attempt tomorrow. There's a lot of reasons why it is. Exercise the team through the initial part of the countdown. See what we can learn up to the T-minus 1 hour, even if we're looking at only a 20% probability of going tomorrow. So if it's just dire circumstances that we get later this evening with the most recent data, we might choose to stand down, not exercise the team coming on console tomorrow, and then defer to a first attempt on Friday.
Thank you, Arlena and Tim. And then we have one right here in the front of the room.
Hi, Ken Kramer, Space Up Close. Thanks for doing this. Just to follow up on Stephen Young, I think a little more openness would be great, and also the new website has a lot of issues. Maybe you guys could work on that, and more direct information about the launches and the landings and the Twitter feed you had before. It's not there now, and I think that would be really helpful if you could put some of that back. Thank you. So I could ask you all a question. And good luck tomorrow. But let me ask about, go back to the weather, the three of you. You talked about the launch weather, but what about the landing weather and there's been a lot of turbulence, landing weather and the upper altitude winds. What is that looking like for these next couple of days?
Yeah, sure.
About the altitude winds? Yeah.
Well, I think the thing to so as I mentioned, the side boosters for Psyche are coming back to land, not out to a drone ship. And so the benefit of a profile wherein we have ascent and then return to land, the conditions are very common between those that are required for launch and for recovery. And so I think it's just important to highlight that we'd be looking at those same conditions essentially for ascent and recovery. And you can talk about the weather.
Yeah. So to add on to what you just said, we have a vast array of monitoring equipment here at KFC and Cape as well for both launch and landing. And we're constantly monitoring that and providing that information real time with that. There's a lot of intercommunication to make sure that we're staying within the limits, and also not just what's actually happened, but forecasting what we expect to happen based on the trends that we're seeing as well.
Thank you. And now we're going to go to the phone lines. We have Jeff Faust from Space News. Are you with us?
Yeah, good afternoon. Question for Henry Stone. You mentioned the changes in the flight parameters because of the thruster issue. How will that affect spacecraft operations, particularly when you get to Psyche? Will you have to change how you orient the spacecraft or handle other spacecraft operations when you get there because you're operating the thrusters differently? Thanks.
Yeah, that's a good question as well. We don't anticipate any changes to how we're going to actually fly the mission. The adjustments affected some of the timeline margins that we already had, but we'll conduct the same operations when we get to the body, so there'll be no impact.
Thank you, Henry. Next on the phone, we have Sawyer Rosenstein from NASA Spaceflight.
Hi, thank you for taking my question. I have two quick ones for you. First, I know that SpaceX just tweeted that Psyche is a big priority in terms of upcoming missions. Are there any kind of rules that are in place to define that priority, especially with, I know there was the Starlink attempt that scrubbed a few days ago. And the second question would be, I know they're talking about reusing boosters now with the Cat 3 certification. Is there any potential for NASA to reuse fairings in the future? Thanks.
I'm happy to.
You take the priority one.
Sure.
And I'll add it.
Yeah, so like I said, everyone at SpaceX is incredibly proud to be supporting the Psyche mission. We've been working here as a team for quite some time, and we were so honored to have Dr. Elkin Stanton give a brief to everybody at SpaceX. And again, we're just so proud to be supporting the Psyche mission and the suite of science missions we have coming up. One of the things that we do in close partnership with NASA and the Launch Services Program is make sure that we only fly when we're ready to fly and when the vehicle is safe to fly. And one of the key aspects of that is post-flight data review, basically making sure we're looking tip to tail, not just at the vehicle that we're launching for this mission, but also the suite of missions we have launched prior. Psyche will actually be our 271st launch of Falcon, Falcon 9 and Falcon Heavy. So we have a lot of amazing data about our vehicle, how it performs, what we expect. And we want to make sure that we preserve sufficient time to partner with NASA to make sure that data is reviewed. So the specific instance you're talking about, we wanted to make sure as an integrated team we had sufficient time to review all the possible data that we could to make sure Psyche was flying and safe to fly. And we're excited for tomorrow. Do you want to touch on the flaring part?
Well, I'll just add, obviously, the separation from previous launches to a NASA launch, that's something that LSP is involved in, and we have requested certain setbacks, and SpaceX has accommodated our request, and we thank them very much for working with us on that. What that setback from a prior launch, and we did ask them to stand down on the Starlink earlier this week, it gives our team time to review that prior launch's data to see if there's anything applicable that we would want to know before we commit to a Psyche launch. And so our team was busy on the LSP side of looking at the Starlink 7-4 data, which had launched very early Sunday morning. And so we asked them to stand down on a Starlink here. SpaceX accommodated that request. We have a very close partnership with them on this specific topic, and we do a lot of dialogue before those committing to the NASA mission. And so we appreciate that, Juliana. Thank you so much. As to reused other hardware other than sidecore boosters, we weren't ready for reused fairings on Psyche, and early next year we probably won't be ready for our first couple of missions in 24. But we have begun the dialogue, and we are working with SpaceX, and I do see LSP and NASA reusing fairings in the future. Now, is that late 24 or early 25? That's probably the general time frame that I would guess.
Thank you, Juliana and Tim. Before we get back to the room, we do have one more on the phone. Jim Siegel from NASA Tech. Are you with us?
Yes, I am. Thank you for taking my question, and hi, everybody. I'm curious about whether, given potential weather delays, if at some point, depending upon the number of delays and the amount of time, will it be necessary to bring the spacecraft back into the hangar to do any sort of resets or replacement of parts or whatever? Thank you.
There should not be any reason why we would have to do that at this point. The spacecraft's got a very large battery. We're charged up and we're ready to go, so we don't anticipate that need.
Thank you, Henry. All right, let's go back to the room. We have one here on the corner.
Hi, John McGill from Wyandotte Cable TV. And this question is for NASA and JPL and SpaceX. Besides the Cat-3 being a first, are there any other firsts for this mission with the electronic drive or anything like that?
Well, the first is the first use of the Hall effect thrusters, part of our electric propulsion system for a planetary mission. It's used for Earth orbiters, but this is our first time taking it out into deep space. So we're very excited about that, and I think that's going to open up a lot of other opportunities for future missions as well.
Thank you, Henry. Back to the room. We have one way in the back. Just give us a moment to get you a microphone.
Actually, can I add to that last
Oh, yes, please go ahead.
Yeah, so the other thing that we have for the first, of course, is we have the tech demo of the Deep Space Optical Communications, so DSOC is flying. We're really excited. You know, you think about when we put fiber optic cables in here to increase our ability to talk on Earth, DSOC's going to do that for us in space. So that's a really exciting thing for us too.
If I may also add, this is our first Falcon Heavy launch for NASA. It will be our 8th Falcon Heavy overall, but it is our first Falcon Heavy launch for NASA. So we're excited about that.
Thank you all for tag teaming that answer. Now we have another question way in the back there.
Yes, hi, Will Robinson Smith with Spaceflight Now. Thanks for taking the time to answer our questions. Question for Juliana. With the Falcon 9 boosters well on their way towards 20 total flights, and this being, I believe, the 5th time that these side boosters will be used, or 4th time, is there a current limitation on the reuse for the side boosters, and does the process differ for reevaluating them for further flights? Is there any daylight between those and just your classic Falcon 9s? Thanks.
Yeah, thank you for the question. So I mentioned this in my introductory remarks, but I really have to give credit to the NASA Launch Services Program for embracing reusability and really not just partnering with us on, they've really partnered with us at the technical level. So at every single, NASA has reviewed every single component on our launch vehicle, at how many flights each individual component is qualified for, and like I said, we only fly when the vehicle we think is ready and safe to fly. And so for all of our boosters, it's not as simple as, this many flights and you're good. We look across not just, the individual component qualification, but also the post-flight data. We actually get the data back from each recovery and look to see if that vehicle is ready to fly. So I don't have an easy number to give you of how many flights NASA is good for, but I will say that it's a technical discussion we have in partnership when we look at the actual data. So Psyche's side boosters have flown 3 times prior to Psyche, 2 Space Force missions and a commercial mission. So Psyche will be their 4th flight. Yeah, I think that was answering your question.
Thank you, Juliana.
I can just reinforce, like where we are within NASA LSP right now on reflight, as Juliana mentioned, a lot of partnership, a lot of analysis of the as-flown hardware, and we've shown that we've flown 5th boosters. We're about to fly 2 4th flown, or this would be the 4th flight. When Europa Clipper uses these side boosters, it'll be their 6th flight. That's the family of flights, as you can kind of tell, that we're comfortable with today, but we're always continually looking at data and trying to push that forward.
Thank you, Juliana. Thank you, Tim. We do have another phone-in question. Marcia Smith from Space Policy Online. Marcia, are you with us?
Yes, thanks so much. My question is for Henry, and again, it has to do with the thrusters. You've said several times that it's not going to affect the mission operations. It's not going to affect when you get there or what you do when you get there. What would have happened if you had not discovered this pre-flight? What exactly would have been the impact on the mission? And at what point in the mission would you have discovered there was a problem?
There would have been a potential risk of overheating the thrusters and damaging them. So it was a serious issue that we had to deal with. And we would have probably discovered that right away had we not caught this and done the due diligence that we went through. And that's why we took that extra week to make sure that we could thoroughly review, get many different sets of eyes on the testing and the changes that we were making to a select subset of parameters.
Yeah, and I think it's important as well just to give a shout out to the team for the fact that they found this and the work that they did. You know, it seems like, well, you know, we lost 7 days of the launch window, but we discovered this asteroid in 1852, and people have been waiting a long time to go study this asteroid. And when you've put all this effort into your mission, you take that extra time to make sure it's perfect. And so, you know, I really think the team deserves a lot of credit for doing that work to make sure this mission's a success.
Yeah, I think, you know, we didn't have to do the testing that we were doing in preparation for operations. You know, we just kept going right to the end, make sure that as much as we can do before we would launch to ensure the success of the mission. It's a huge investment, and all the people involved in the project wanted to do that. Obviously, right? We've got a personal commitment for many years, and all want to see it succeed. So yeah, I'm very proud of the team for tracking it down and the heroic effort to address the issue in the time we did.
All right, thank you so much. So that is all the time we have for questions today. I want to thank our panelists for joining us today. Of course, thank you to the media for participating, and for those of you watching online, we appreciate your presence as well. As a reminder, Psyche is set to launch aboard a SpaceX Falcon Heavy tomorrow. That is October 12th at 10:16 a.m. Eastern. Live commentary is set for 9:30 a.m. Eastern on NASA TV and NASA.gov/NASA TV. We also ask that you'd please tune in today to the NASA social panel streaming on Facebook and X at 2:30 p.m. And until next time, go NASA, go SpaceX, and go Psyche.